So we're moving into a new part. So we've talked about slope, we've talked about y-intercept, we've talked about direct variation type relationships. Now we're going to start talking about how we can change the equation of a line to make it look different. So we're basically going to be learning about the properties of the different parts of a line. So we've been learning about lines in slope-intercept form. So we have M and B, and those are the two changes we're going to learn about today. I want you to make sure that you use 2 pages because I want these two to face each other because they go together. So let's go ahead and we're going to start by talking about changes in M, which is slope. So first of all, I want you to just draw a small graph. Okay. Here's my X and here's my Y. And just draw me 2 lines, okay? One that's steeper and one that's flatter. Okay, and we're going to label those. So I'm going to say that this one is steeper and this one is flatter. Okay? So we're going to start by talking about how changing slope affects how adjusting the slope can make changes to graphs. Okay, so first of all, as we should know, M is slope, which is how steep the line is. Okay, so if we think about slope as how steep the line is, we can also think about that as if we're thinking about a real-world problem, like how fast something, like how quickly something is increasing. So if something is increasing like if you're going up 1 mile every hour, you're not increasing as quickly as if you're going up 3 miles every hour. Because think about like walking. If I'm walking 3 miles, if I'm walking 1 mile an hour, I'm basically not even walking. But if I'm walking 3 miles an hour, I'm walking faster. If I'm running 6 miles an hour, I'm going faster. So the higher my rate gets, the steeper my movement is. If I'm going flatter, so for example, if you're going 3 miles an hour and then you slow down and now you're going 1 mile an hour, then your line is going to get flatter if we were to graph that, your progress. Okay, so slope tells us how steep the line is. Okay, so first of all, if the line is steeper, okay, so if the line is steeper, this means that the slope or rate of change is further away, is further from 0. And what I mean by that is when I say something steeper, I'm saying steeper than something else. That something else that we're talking about is the parent function, which is in the previous video that you just watched. So the parent function is, when we talk about steeper, we're saying it's steeper than the parent function. Well, the parent function is 1. But let's say let's say the example we were using was I started by walking 3 miles an hour, and then, not that this would happen, I started running 6 miles an hour. Well, then I got further away from my slope, got further away from 0, and that made my line get steeper. Okay, so when my line is steeper, my slope or rate of change is further away from 0. Okay, let me make this a little. There we go. Now, likewise, the language that we use for that, we say the line is vertically stretched. Vertically stretched. So basically what they're saying is when you make that line get steeper, it's like you're stretching it. And I'll show you all some pictures of what that looks like tomorrow. Okay, so it's vertically stretched. So this is like the official, so like before you might just say, oh, it's stretched or it's steeper. The official 8th grade or 9th grade algebra lingo is vertically stretched. Okay? Now, if the line is flatter, okay, so if the line is flatter, that means the slope or rate of change is closer to 0. So it might be a fraction. It might be I go from running, I run for about like 1.3 seconds, which is about how long I could run 6 miles an hour, and then I slow down to 1 mile an hour, basically just bending over and breathing really hard. Okay, so my rate of change my line would have gotten flatter because I would have gone from this 6-mile-an-hour line going really fast for about 3.5 seconds, and then to basically passing out at 1 mile an hour. Because I would have slowed down, my line would have gotten closer to 0. Okay, the official algebra lingo for that is we say the line is vertically compressed. Okay, so when we stretch something, so when we compress it, like if I took this line and I smushed it down, it would get kind of like flatter. So when a line gets steeper, it's vertically stretched. When it's flatter, it's vertically compressed. Okay? Now, about slope. If we talk about, so when we talk about how steep a line is, we look at absolute value. Which is how close it is to 0. No integer sign. Okay, so we don't look at the integer sign. So if I was to put these numbers, these slopes in order, so -1/4, 6, let's say -6, -3, 2, 1/2, -3/4. Okay? If I asked you to put those numbers in order, you'd say -6, -3, -3/4, -1/4, 1/2, and 2. Because you'd be putting them in order from the least, which is the most negative, to the most positive. But when we order steepness, we don't do that. We don't look at the signs at all. I look for the number that's closest to 0. Well, the closest to 0 is -1/4. The next closest to 0 is 1/2, then -3/4, then 2, -3, -6. I only look at the absolute value of those numbers when I order numbers in terms of steepness, because the only difference that this negative sign means, which let's talk about now, is if the slope is negative, the line goes downhill. From left to right. So remember, if I have a line that's going like this, and I have a line that's going like that, pretend those two lines are equally steep. Let's pretend that these both have a slope of, this one has a slope of 1, this one has a slope of -1. Okay, that's my slope of 1, that's my slope of -1. Okay, well, they're equally steep. I would have, if I decided to walk up this hill this way, it would be equally as difficult as if I walked up this hill. The only thing is, this one's going uphill and that one's going downhill. So the sign doesn't necessarily matter when I'm talking about slope. Okay? All right. Changes in y-intercept are actually a lot easier. They're a lot quicker because there's really kind of less to talk about. Okay, so when I look at y-intercept, let's draw two lines. Let's draw one here and one there. Okay, now these two lines happen to be parallel, but that doesn't necessarily matter. Okay, in this case, I have two different b values, right? They're basically, we're not worried about slope right now. We're just looking at y-intercept. Okay, so this is my b. Oops, I'm sorry about that. This is my b, which is my y-intercept, which tells me how far up or down my line is shifted from 0, 0. Okay? So the y-intercept tells me how far up or down my line is shifted from 0, 0. Okay? So when we, if I have, so when my, if the y-intercept is greater than, well, is bigger, let's say if the y-intercept gets bigger or more positive, the line shifts up. And the official algebra lingo is the line is translated up. That is the official algebra lingo. Okay, so this line is translated up. And however many jumps, so let's say that this is at 0, 1, and let's say this is at 0, 5. This line is shifted up 4. So let's call this line 1, line 2. So line 1 is translated up 4 from line 2. So line 2 is shifted up. So if I line 1 is 4 above line 2. It's translated up 4 from line 2. Okay? Okay, so let's try this one. Okay? If the y-intercept gets smaller, that means the line shifts down. And it means, in our official lingo, the line is translated down. And if I look at this picture again, if I want to see how much it's translated down, line 2 is translated down 4 because 5 minus 1 is 4. So it took 4, it went down 4 hops to go from line 1 to line 2. So I could write that. Line 2 is translated down 4 from line 1. Okay, we will practice this and talk about it some more in class tomorrow. Make sure that you write down any questions that you have, anything that did not make sense to you, so that you can ask me questions in class tomorrow. If you're not asking questions, I can't answer questions you don't ask.